Hello, everyone, and welcome to our session on Beyond Endpoint Security using Osquery at scale. This session will be jointly presented by my colleague Prateek Nischal and myself, Prasoon. We both have been working in the field of endpoint security for a couple of years now. And before we get started, let us quickly introduce ourselves. So over to you, Prateek.
Thank you, Prasoon. Hello, everyone. I'm Prateek, and I work as a senior software engineer at Walmart Global Tech India, and I've been working as in the field of information security for close to 5 years now. Yeah, thank you. Back to Prasoon.
Thank you, Prateek. Hello, everyone. My name is Prasoon Dwivedi. I work as a staff software engineer at Walmart Global Tech. I have been working in the field of information security for almost a decade now. Software development and open source software development are few of my areas of interest. During this session, we request you all to keep posting your questions. We will be taking them towards the end of the session. Now, coming to the main agenda of this session, we'll see what endpoint devices are and why they are important for an organization. So in a typical enterprise setup, there can be hundreds and thousands of devices ranging from virtual machines, servers, PCs, and associate laptops. So all such devices act as a gateway to the enterprise network. An adversary may exploit a vulnerability or a security misconfiguration in one of these devices to get into the enterprise network, where he may set up a command and control center or may laterally move to different other devices within the network. Finally, he will carry out his intent. His intent can be to compromise the integrity of files present on such systems, bring down a business critical service, or to exfiltrate data outside the network. But endpoint security doesn't just end at preventing a malicious actor from getting into the enterprise network. It's much, much, much beyond that. It is also required for continuous compliance. So your business may be required to comply to one of the many industry standards and regulatory framework, such as from NIST, PCI DSS, HIPAA, SOX, etc. So these frameworks and guidelines may dictate that you have some kinds of processes and protocols established within your organization in order to secure your endpoint devices. These frameworks and guidelines may dictate that you patch your endpoint devices frequently at a fixed cadence. You preserve the integrity of all the sensitive files present on these systems, and you account for all the activities which happen on these devices. Now, moving on, we will see a few of the challenges in maintenance and security of these endpoint devices within an organizational setup. So the first challenge is with the visibility. It is already a challenging task to maintain an inventory of all the devices which may be present in an organization. But it becomes a more daunting task for an administrator if he has to find out list of all softwares or packages or running processes on all devices within the enterprise network. The next challenge is with the pace with which cybersecurity landscape is changing. So a endpoint security solution, which is perfect today, may become outdated tomorrow if it's not kept updated in response to latest trends in cybersecurity. We also tend to overcomplicate endpoint security. Let me ask you a question. How many of you have complained about antivirus or anti-malware software installed on your devices consuming a lot of resources? I assume almost all of you must have at some point or the other. So gap in one security solution is often compensated by bringing in another security solution. Security, just like any other thing, comes at a cost. This cost is measured both in terms of money as well as resource consumption. So if we install a number of endpoint security agents on a device, it's going to hog a lot of resources. So much so that it's going to impact the correct functioning of legitimate business critical applications. Accountability and ownership is also an issue while dealing with endpoints and endpoint security. Endpoint security devices in a enterprise network may be spread across different business functions, roles and responsibilities. And this ownership and identity information is generally kept in a system which is outside endpoint security devices. But at the time of a security incident, it becomes a challenging task to correlate and filter all this data in order to find the right team or the person who will be ultimately responsible for mitigating that issue. We also tend to over prioritize anti-malware and anti-virus softwares a lot. A virus or a malware is not the only thing we look out for. Uh, there are things which fall um, outside the general threat window, um, and we need to consider those things as well, such as regulatory and compliance requirements and policy enforcement. Both these things are very critical when we choose an endpoint security solution for our endpoint devices. Now, moving on, let's see what are the requirements from an endpoint security solution. So, endpoint security generally starts with installation of agents on devices. So, as we have already discussed, in a enterprise setup, there can be a large number of devices, and probably they are going to be heterogeneous in nature, and may require a different, and we may require a different kind of agent for all such devices. But endpoint security doesn't just end at installation of endpoint devices. We also need to set up an immutable event pipeline. So through this pipeline, we can detect any changes to the state of endpoint devices. We can collect them, annotate them with metadata and contextual data, and finally transport them to a place where they can be used for further analytics. We also need a triaging and alerting setup. And alerting setup is needed, and it needs to be smart enough so that it can detect any abnormal behavior throughout the enterprise network and send out an alert to all the required stakeholders. This alert also needs to be actionable in nature. A fast, reliable, and easy to use triaging setup is also needed. This setup will be used by auditors and administrators to derive in, meaningful information from all the collected logs and events. Finally, all the data, logs, and events we collect from all the devices present in a network should be open to stakeholders. It's not exciting at all if it just sits in a data store. Um, if it's made available to stakeholders, probably they are going to use this for their further analytics and use it for purposes such as threat detection and inventory management. Now let's see what are the requirements from a compliance point of view. So an endpoint security solution must be able to detect a vulnerable enterprise infrastructure. In order to do so, it needs to track all the installed software and packages along with running processes on all devices throughout the network. Then, finding a vulnerable infrastructure becomes an easy task, and in order to do so, all we need to do is to look out for vulnerable packages and compromised processes. We also need visibility on what all is running on an endpoint device at all the time. We also need to attach and associate all these activities to a user or a service account. An endpoint solution should also provide strong proof of its own integrity. In order to do so, it must run in a self-aware mode and should be able to detect any changes to its subcomponents. Um, by doing so, it can easily detect if it has been compromised or tampered with. Finally, for all the auditors, it's important to know what all different components of an endpoint security solution is running on a given device at a given time. So all this information should be made available to the auditor and administrators. All right. Once we have selected an endpoint security solution for our enterprise, we'll run into the problem of bootstrapping. In the bootstrapping phase, we need to find an efficient and fast way to deploy the solution across the network. There are a couple of broad steps involved in this process. So let's quickly take a look at all of them. The bootstrap process will start with installation of event collectors or agents on all the devices. Then we need to finalize a way through which all these collected events can be sanitized and converted into a standard format. We also need to set up a trusted and reliable pipeline to transport logs and events from endpoint devices to the centralized collection framework, where they can be used for further analytics. Finally, we need to set up a command and control center through which configuration can be distributed and behavior of agents can be controlled by making micro changes to the agent configuration. All right. Now that we have discussed the challenges in dealing with endpoint devices and requirements for a endpoint security solution, we have prepared a wish list of items which we would like to see in an endpoint security solution. So again, it's not an exhaustive list, but here are a few of the items we have on top of our heads. So this security solution should have no or minimal custom or complex deployment. It should ensure its own integrity. The ownership and identity information should be made integral part of the solution. There should be a single point of control through which behavior of agents can be controlled and monitored. And finally, it should not require a establishment of a new logging framework or a logging pipeline. It should use the existing org native logging framework for building the eventing pipeline and transporting logs from endpoint devices to the collection point. So keeping all the items in the wish list in mind and with the intent of solving the challenges we face while dealing with endpoint devices, we have worked on an audit framework for endpoint security. So this audit framework of ours is based on Osquery. Osquery is an open source endpoint visibility tool. It was created at Facebook. Osquery exposes operating system events and information via SQL interface. It also has strong capabilities for filtering and correlation already built into it. So one may ask why we choose Osquery for our auditing framework. So there are a couple of reasons for it. The first reason is Osquery is extremely flexible. Osquery follows a plugin-based framework, and there are a couple of plugins which are shipped off the shelf with Osquery. There are two such plugins which are of our special interest. The first plugin is the Tls config plugin, and through this plugin, we can read configuration from a remote host. The second plugin which is of our interest is the Tls Logger Plugin, and as the name suggests, this plugin can send logs and events to a remote destination, which implements the Tls plugin, of course. Both these plugins can be extended to support custom functionality and features. Now moving on, let's see what our audit framework is and what it does. So the audit framework is nothing but a set of guidelines which tells how different components of an endpoint security solution must act and behave. It aims to standardize the way agents behave, how they act, how they collect events, how they process it, sanitize it. It also tells one how configuration should be distributed and how integrity of configuration can be maintained throughout. It also tells how logs can be transported from endpoint devices to the centralized log management system. So we have a full-fledged implementation of this framework for Linux systems. This project is built on top of Osquery and is tightly coupled to the Linux audit framework. We'll be sharing a link to this project towards the end of our session. Now let's see how the audit framework we have proposed uh, ensures its own integrity for compliance purposes. So in order to do so, the audit framework keeps on monitoring its own subcomponents, such as version of the agents deployed on endpoint devices and their integrity. The framework also detects any changes to the permission of an agent with which it's running. It is important to monitor any change to the agent permission because it may hamper its an agent's ability to look into OS events. It also keeps track of the time for which an agent has been running. It also detects agent restarts. Agent restarts are of our special interest because those are the dark period when we lose our ability into an endpoint device. And finally, it also keeps track of any configuration which is loaded onto an endpoint device, uh, which is outside the distributed configuration and loaded through side channels such as command line interface. Now coming to identity and accountability. In order to correlate and process data collected from different endpoint devices, uh, in an enterprise, we need some more contextual data, such as where the event originated, what agent and what config was used to detect any change and emit out the event, and who the owner of that endpoint device is. And in order to do so, we can annotate the event records with a lot of meta information, such as we can use hostname and IP to uniquely identify the endpoint device. We can use agent version and the version of the config the agent is running with to identify which agent was used to collect and emit this event. And for ownership information, we can use data such as organizational segment, pillar, or the geographical location, along with the name and email address of the team or the individual who owns that device. All this information, all this metadata can be fed to the audit framework at the time of bootstrap by the orchestration engine. So all this process can then be made automated and self-serviced. So I'll stop here and pass on the control to Prateek, who will take us through the next segment of this session. So over to you, Prateek.
Thank you, Prasoon. Configuration is another area that the audit framework deals with. Configuration is one of the most important components because of its dynamic nature, and it defines how the agents should behave. Agents may be extremely capable of collecting information, but they're only as good as they're configured, right? Configuration, the updates for configuration could be for something like updated malware definitions, additional information that you might need to collect, updated frequency data collection timelines, etc. For our implementation, the configuration is managed by a custom Osquery config plugin that can handle configuration for not only Osquery, but all of the agents that may be running on the endpoint. The audit framework describes multiple ways to serve the configuration in order to make it performant as well as secure. For example, the configuration could be served out of a out-of-the-box file server or a full-fat API server, depending upon how complex is your setup and what is the level of flexibility that you might require. For instance, if the configuration required by an endpoint depends on its runtime state, you might want to go the API route. If the resources are static enough, you can serve it from a simple file server. Now, another thing is confidentiality, integrity, and accountability. How do we ensure that? So the configuration derives its security from an already established and available technology amongst organizations, which is public infrastructure, which is usually present for signing X509 certificates within an organization, which may be used for server certificates, client certificates, artifact signings, etc. The configuration, all of its versions and metadata are bundled and protected under a security envelope which is protected by a digital signature. The trust anchor for the digital signature is the organization CA. The certificate that is used to create the digital signature can be access controlled logically, as well as using X509 extensions and attribute so that the certificate is only used for the actual purpose and not for anything else. It should be very difficult to forge a signature for this certificate. Now, why do we want to secure the configuration explicitly? Why not just rely on TLS or some other standard mechanism? So there are some benefits that we get from it. For example, the configuration can be served from an insecure file server. You do not have to spend effort or time on securing the location from where the configuration is served because the configuration has built-in security. Also, it allows us to verify the configuration irrespective of its source. Say, if you happen to find a configuration bundle just lying around in some place and it has the signature attached to it, it would be very easy to verify the configuration to make sure it's valid or not. The audit framework also defines a mechanism to get the configuration via a simple anonymous HTTP GET request, which makes it very painless for orchestrators to integrate. This also allows for higher performance because if you stick in a caching proxy in front of it, you might get a very linear scalability. The configuration and its security is tied to the PKI and not a shared secret, which makes it completely self-service and automated. Anyone who wants to onboard the service may not require to communicate or have any interactions with the solution providers, which makes it a bit more streamlined in terms of automation and onboarding. Another area with which the audit framework deals with is integration with the native auditing component of the platform. For our implementation, since we are focusing on Linux, we would be using the Linux audit framework. The Linux audit subsystem, or KAudit, is a very powerful kernel feature that lets us extract a lot of information regarding the state of the platform and what's running on it. But it has a cost, as all good things have. So what are the capabilities of KAudit or the Linux audit service? It can help us gather information about process execution, which can help us to detect malware and its footprints, syscall auditing for process, file integrity and access monitoring for sensitive files, ability to monitor user and network activity on the endpoint. The Linux audit system, or KAudit, is very comprehensive, but it's not very flexible in terms of configurability. The usual way to configure KAudit is using auditctl. It does not support globbing or pattern matching. You might not want to monitor everything under the sun, but very specific file patterns, which is kind of difficult using the Linux audit framework, at least in the vanilla version. The logs that are emitted by KAudit are not very processing friendly. It's hard to make sense of the logs immediately. It's optimized for performance and not for immediate visibility. Although there are some certain tools, such as Audit Beat by Elasticsearch or Go Audit by Slack, which try to make sense and extract relevant information from the logs and make it accessible for standard log aggregation and correlation tools, but they're built on their own ecosystem and it may not play very well with the components that are already running on an endpoint or an organization supports. Now, for a 2-minute primer on KAudit as to how it works. It's like a silent watcher sitting at the kernel gateway, looking at the syscalls as they come in and the responses go out. And for the rules that it's configured with, it can create events and pass it to user space for consumption over the audit netlink socket. So audit and Osquery both are clients to these audit netlink socket, which can consume and post-process logs. Audit does not do any post-processing that makes the event stream fairly noisy and hard to gain insights from. Osquery, on the other hand, uses userland filtering to make sense of the logs, annotate it, and enrich the data. But the way it configures KAudit can lead to a lot of uninteresting events hitting Osquery, which can aggravate the already potentially lossy behavior of KAudit and add to the unnecessary resource consumption, which is always a problem with endpoint agents. Now, because of all of these uninteresting events, this could lead to buffer overruns, which can lead to the interesting events getting lost because Osquery would be too busy dealing with the existing events that are coming in. And it might as well drop all those events because most of them are not very interesting. Now, to back that claim, we have a benchmark. So this is a benchmark of Osquery running on a Linux machine with all the vanilla configuration. And you can see that the CPU overhead is quite noticeable. This can lead to instability in terms of processing logs, which means you can drop certain events. Osquery could get unstable. The resource limiter for Osquery might kick in and you might get into a dark area. Now, on the other hand, this is a benchmark with Osquery running on the same machine, but with a manually configured KODD system. Notice the CPU consumption. It's virtually non-existent, right? Now, this is because Osquery is no longer processing all of those irrelevant logs, but only the logs that it needs to process. This shows that Osquery can offload a lot of the audit configuration and processing part to an Osquery extension that understands and configures the audit system in a much better way. That can lead to much better performance and virtually no user land filtering overhead, since the number of irrelevant events would be reduced by orders of magnitude. Now, this brings us to Osquery extensions. Osquery, being flexible, allows us to implement event consumers and configurers, which can also utilize the full suite of Osquery SQL filtering capabilities and also annotate the data with all of the relevant tags that it might have been configured with. This can help us get the best of both worlds. Now, once we have the logs, we need to act upon it. Every organization who deals with IT has a log shipping mechanism with a dedicated process around it. It's much more efficient to just reuse that pipeline instead of building a custom event pipeline because it's something that is core to the infrastructure and the organization. You might want to just reuse that. Once the events are under a querying or a correlation engine, the events can be checked for dead agents, configuration changes, integrity changes, and any other relevant events. The events could also be passed through live deterministic classifiers to detect suspicious events like unauthorized use and modification of resources. For example, not all users are allowed to run processes on a machine or log into a particular resource, etc. They may not be allowed to view or modify a particular file. It may sound like there is an underprivileged or a non-privileged user who is trying to modify a certain system configuration. That might be something suspicious, right? All of these rules can be encoded into a rules engine, which can provide near real-time alerts. The data is also semi-classified because of the native tagging that it's already integrated with. It has a lot of context within the data. For example, what was its source? What kind of event was it? Was it a user event? Was it a process event? Was it a network event? What time did it happen? What was the region that it came from, etc. All of this data can be fed into a machine learning model, which can use to calculate a threat score for that particular resource. And if you map out this threat score throughout your network, you might be able to identify hotspots on your network. Now that is an indication that you might want to have some additional controls over those resources because they seem to be most active all the time. Now, since we have all of the data and it's historic in nature, like we have aggregated the data over a certain period of time, all of that data could be used to generate reports for regulatory bodies, construct an audit trail, and a database for triaging. The resource owner have an idea about what is running on their endpoints. And if we give them the information about what was actually running on their endpoints, they might be able to make more sense out of it and be able to fix it preemptively before even it causes any problem. It can also serve as a tracking mechanism for ownership, which may be difficult for some organizations. This kind of covers all of the resources. So far, we have talked about only the Linux platform, which is part of our implementation, but can the audit framework be applied to other platforms? The answer is yes. So if we look into the Mac and Windows ecosystem, Windows has Windows event logs and Mac OS has endpoint security framework that can be swapped out for the Linux audit framework in the whole pipeline, and you can get similar properties and similar eventing behavior throughout the pipeline. So it kind of makes it native to all of the platforms. Now, as part of the project, we would want to enhance it. We would want to make it available for everyone. For example, we would want to support distributed query mechanism for a live view of resources and not just using Osquery, but through all of the agents. We would want to make the audit rules flexible and expressive that would lead us to generate even leaner events and efficient resource utilization. Osquery today does not parses all of the information that is emitted by KAuditD. We would want to add a bunch more tables so that we can make use and leverage that information from the audit logs. Lastly, we would want to publish all of the configuration for the agents and eventing pipelines, which may serve as a starting point for anyone who is trying to play around or want to try this framework out instead of scrambling to figure out how do I configure this agent, how do I install this agent, etc. It should be accessible to everyone. Now, how do you apply this information that you have gathered today? Now, hold that thought. Let me put up a question or a set of questions actually in front of you. For example, how long does it take for you to track an event to a particular resource? What controls does your compliance require? What are the data points that you need? How complex is your infrastructure? And let me put up another set of questions. Do you already have an alerting logging mechanism and an artifactory as first-class citizens in your infrastructure? How many endpoint controls do you have and how many of them are redundant? And how visible are your servers? Which means, do you know what is running on your endpoints and who is running them? If you're familiar with the first set of questions and have answers to the second set of questions, you can apply or even build upon the audit framework for your infrastructure. Details about the projects can be found in the OpenOSquery organization over at GitHub. It has a bunch of repository and it has all of the information that we have presented today. And feel free to check it out. Also, it's a work in progress repository, so keep an eye for updates. And we are always happy to have you on board and with your contributions. Thank you.